OpenTelemetry is getting a lot of press these days. I talked today to Confluent engineer Xavier Léauté about the role it plays in the overall observability solution behind Confluent Cloud itself. Listen in on today's episode of Streaming Audio, a podcast about Kafka, Confluent, and the cloud. Hello and welcome to another episode of Streaming Audio. I am your host, Tim Berglund, available these days as an audio feed and on YouTube as well. So check that out if you're the sort of person who likes to consume your podcasts as video artifacts. That's a thing you can do. I'm joined in the studio today by my coworker, Xavier Léauté. Xavier, welcome to Streaming Audio.
Thank you, Tim. It's a pleasure to be here.
We are going to talk today about OpenTelemetry. Now, this is one of those things. 6 months ago, I had heard of it, but just barely. It was like not on my radar at all. And now, let's just say my radar is full of little pings to do with OpenTelemetry. It's on everybody's mind, and it seems like a thing everybody's talking about. So I want to dive into what it does, what it is, and talk about implications for Kafka and Confluent Cloud and just whatever you got. But first, could you tell us a little bit more about yourself? What do you do?
Yeah, so I work on the engineering team here at Confluent. One of my primary responsibilities here is kind of leading all our what we call observability effort. I think it's a pretty broad term, especially at Confluent, since we have both internal needs and external customers. Both of those want to have visibility into the systems we run. And oftentimes those are the same systems. So the systems we maintain and manage for our customers are the same that our customers also want to have visibility into. So it's kind of a very cross-cutting role, maybe different than some of the other companies out there that just do this for their internal purposes. So this role also makes it an interesting challenge to work on these problems. And that's kind of been my focus for most of my tenure here at Confluent, starting out with some of the more on-prem concerns, and then now moving on to the cloud, where now we're full steam getting all these things out.
Quite so. And observability, I guess we used to call that monitoring and alerting and things like that. It's kind of the not just the new word, but a slightly broader and more inclusive category for that set of activities, wanting to know what's going on with a system that you're operating. Does that sound fair?
I think that's fair. I think there's a lot more people with much stronger opinions about what these terms means out there on Twitter. You can find
those are productive debates.
People that work at Lightstep or Honeycomb can probably tell you more about how they think about these things. I think we address both here, and I mean I think for in the way we use this data is actually both for observability and for monitoring. I think today we're mostly covering the monitoring aspects, but we're adding more and more of the observability part, which is really debugging the system that you're trying to when you're trying to understand when things go wrong, rather than just like, okay, well, I just want to have some health indicators, which is what monitoring is about. Like, I'll probably stop there before like other people start complaining about what I say, but
before we get into
the contentious
this
parts.
Is like asking what a developer advocate does or something like that. It's just not something you should do on a podcast. It's too political. Anyway, tell us about OpenTelemetry. Like, assume I mean it is a relatively new thing in terms of its participation in the popular community consciousness. Just as a piece of technology we talk about. So assume listeners don't know what it is. Is it a set of standards? Is it an API? Is it infrastructure? Like, what is it?
It's in some ways it's all these three things combined, which is actually the nice thing about this. So these efforts started out. I think people that have been working in the space probably know about open tracing, which was basically an API standard for people to instrument their applications and get traces collected without having to use vendor specific APIs. There was also a project from Google that was addressing more the metrics side of things, which is called Open Census. And so these two projects basically decided to join efforts and be like, well, we should be providing these like becoming the standard to instrument your applications. So, and they went a bit further than what Open Tracing did initially, which is to actually provide both the APIs to instrument your applications, but also define the formats that this data would be collected in. And the nice thing about that is that makes it your system's completely vendor agnostic, and you can then send this data directly to various different observability providers or monitoring providers without having to, install custom agents or things like that for every single vendor that you want to integrate with. So you basically now can instrument your libraries once, instrument your applications once, and then get all this data wherever you want it to, without having to redo the work every single time you want to switch from one vendor to another, or use the data yourself for that matter.
So that instrumenting step, is that how should I think about that? Is that a library that I code against? Is that a step in the build process that goes through my Java bytecode and does things to it? I mean, what's
So
that
there's
like?
various levels of how involved you want to get in the process. I think most
And by
people
the way, I
start.
just made a language assumption there. I just said Java, and I assume there's support for Java, but maybe talk to us about that little bit of parochialism of mine as well. Maybe
Right.
there's
So,
more than Java.
but there's a lot more than Java. I think the nice thing about these parties, especially OpenTelemetry now, it's really gotten traction. There are many different languages that are supporting it now. There's been implementations for, Java and Go are the two ones that I deal the most with, but there's also Python and JavaScript now. Like, so there's
Oh wow.
the whole ecosystem is really flourishing. So a lot of things coming down, and you can hear more about all these things on the OpenTelemetry Twitch channel or other places where they talk about these things and the recent developments.
Sounds like we should link to that in the show notes. I'm the Twitch channel.
Yeah, so there's a lot more being discussed there, and people go into the gore details of what's happening there. So in terms of these, so you were asking about instrumenting your application versus just letting it do its thing. So um, depending on the language you use, like there are various levels of work involved depending due to the way that the languages work. For Java, you can just have an agent that auto instruments a whole bunch of things and does things for you, and you get a lot of nice things out of the box, which can be useful. Which is kind of similar to what you get out of the box for most, frameworks that do like an API layer and automatically give you traces, and you'll have useful information, but it doesn't tell you anything specific about your application. So you still
Right.
have to go
And when
in
you say
there.
agent, you mean runtime component
That's right. So
that
there would
my
be.
application is just deployed and knows nothing about OpenTelemetry, but here's the agent. And
Right. So in the case of Java, you basically inject this agent. It will go instrument your bytecode, figure out all the classes that it knows about, whether it's like your DRPC framework or your Spring framework, your Drop Wizard framework, all these things. Like it figures these things out and basically adds instrumentation where it sees anything it knows. And it
gotcha.
even does
And
that
it
for
knows
Kafka and
those
things like that.
usual suspects, some set of those usual framework suspects.
That's right.
It's looking for class names to instrument and methods and so forth.
And in other languages, you still have to go do a little bit more work, but they usually have some kind of hooks, and then the framework basically gets into these hooks, and you explicitly have to code against it, but it will take care of a lot of the heavy lifting for you.
Gotcha.
The interesting part is when you actually want to provide more additional details about your own application. So if you have certain attributes or certain properties you want to capture with every single request in your traces, or you want to also inject those things into the metrics that you're collecting. So that's when you have to do a little bit more work. But that's also where it becomes a lot more powerful and interesting, because you have now visibility to things that you care about, which is what this really allows you to do without having to use anything that's like pretty vendor specific or locking you into whichever vendor you're currently using. So you're kind of agnostic to that, and you don't have to worry about rewriting this in the future. So that's kind of the holy grail, so to speak, that we're trying to get to.
Gotcha. And so again, asking on behalf of all the people whose specialty is not observability, That's my version of asking for a friend. Uh, when you say vendor, um, we've got instrumented code. We've got these standard ways of instrumenting code. That's either a runtime thing or a build time thing or an API. Seems like there's a spectrum of options depending
Mhm.
on my language and capabilities of the runtime. What's the vendor? So like this data is going somewhere. It's this method got called, this thing happened, and I'm presuming OpenTelemetry is wanting to send that to something.
Right.
So what are the some things that those are the vendors you're referring to, right?
That's right. So once that data gets collected, OpenTelemetry, you want to actually be able to act on this data. So you want to have some nice dashboards. You may have some APM tools out there you want to use, whether it's Datadog, Nearby Lake, Honeycomb, Lightstep, all these. That's the Dynatrace. There's a lot of people out there, and a lot of them are actually part of these OpenTelemetry efforts now, and really
Oh, cool.
participating, which is the nice thing is that they're all adopting the standards. So you'll once you have this data collected, you can basically send it directly to any of them without having to do anything like changes or adding more, deploying more agents or things like that to your system to get this data into these
Got it.
these
Yeah,
third
because
party
they're a
systems.
part of the standards body, which those
Exactly.
vendors would be. And on the lower level, do you get things like Splunk and Elastic, and it's just sort of more general places to put things, or is that not? Is that a little bit out of the domain?
So there is an effort separately to that's kind of nascent, which is other than metrics and traces, also getting logs through the same system. So making all the log collection kind of vendor agnostic. So that's just starting out. I think that's one of the much more recent efforts in OpenTelemetry, and those will probably integrate with things like Splunk, and I'm sure they will be. Elastic will probably come out with some kind of integration at some point, I imagine. But uh, I know, and Splunk is actually a big uh, participant in these efforts since they also have signal effects and as one of their products out there. So they're actually heavily invested in the standard as well.
Oh, nice. Okay. And it seems like there's probably some Kafka implications. So I want to talk about those. I mean, one imagines, right? Here's these streams of data coming out of the nodes of your application. So, gee, where's that going to go? So, uh, there's probably Kafka implications, and it would be nice to the extent that you can talk about how we use this in Confluent Cloud. It's always interesting to know a little bit about how the product is made. I mean, that's the nice thing about it being the cloud is that if you're building something on top of Confluent things or Kafka, you don't have to care how it's built. You just have some APIs and features, and you get things done. You build your own stuff, but it's always nice to look under the hood a little bit. So, to the extent that you can talk about it, it'd be great to hear how we do things in cloud.
Yeah, so we actually have been early adopters of open telemetry and open census and some of these standards in cloud. And our main motivation there was we're running all these clusters for our customers. We have many different teams working on instrumenting their applications. Um, and those are not just Kafka or KSQL connectors. There's other types of services we also run that are internal services. So everyone wants to have a way to instrument their applications, to monitor them, to get visibility into those things. And so we're hoping to get to a point where we can all follow the same standard, use the same standard to do that, and OpenTelemetry kind of like present itself as that holy grail solution that would allow us to basically give people one way to instrument all their applications and never have to think about it again, irrespective of how we then use this data. So and that's kind of where I want to get to is that since I mentioned earlier, like a lot of these metrics and traces we collect from our systems are actually not only useful to our internal operations, they're also useful to our business, right? So we want to understand how people use the product, how what is the distribution of different usage data across our different clusters or different clouds. And we also want to expose this data to our customers. They want to have visibility into the clusters that they see. Now, everyone doesn't need access to the full granular data that we collect, but everyone kind of wants just a slightly different view of that data. So you may want to have like high-level metrics for our executives. You may want to have very low-level, detailed, fine-grained metrics for engineering teams that want to troubleshoot things down to the specific user or customer or the request type in Kafka. And then we have our customers. They don't see those nitty-gritties. We don't want to expose things to them that they shouldn't have to care about. That should be,
of course,
something that we take care of. But they still want to see, like, okay, well, what is my throughput per topic, and what applications are consuming from which topics, and how much. And so having that data is very useful to them. But ultimately, all these things can be derived from the same source of data. And the way that traditionally it has to be done is that if we want to use whatever third-party tool we use to have our own internal dashboards and alerting, we have to get an agent out there for that and have that collect the metrics. And then we also have to deploy our own agent to collect the metrics for ourselves and then pipe them into our business systems and into our APIs and things like that. So now we're basically getting to the point where we can replace all these things with just one thing. We're just collecting the data once. And then we can funnel it to the different places where we want to use it. So if that's like whichever vendor we're using to do all our monitoring and alerting, we can send it directly to them. We can push it into a Kafka topic to then have that consumed by our data science team and do whatever fancy analytics they want to do on that, and business reporting and all that. And then we also pipe that into our infrastructure to serve to our customers through our metrics API. So basically, having all this data in one place, we can now have funnel that into many different other systems and build new products off of it. And they're all consistent, which is the nice thing, because in the past, someone from the engineering team or the support team may have seen some issue, and then they look at what the customer sees in the API, which is different than what the engineer is looking at in their dashboard. And usually, the source is the same, but the data might be slightly different because of the way it gets instrumented. The namings are not consistent. It gets very confusing very quickly, especially when you have to deal with thousands of different clusters and trying to figure out what's going on. So by having all this data just collected once, we're all seeing a consistent view of all that data, which is very nice. And it's also a standard, which means we can actually use that standard to use that standard to encode this data and then funnel it and build components that will work with that standard, or funnel into other systems that understand the same standard, which is makes this very powerful.
Yeah, it is. And that some things like this I learn even about our own product, and they're surprising. And then I think, why was that surprising? Because it just makes sense. But what starts as, hey, we need to keep on top of this cloud service we're operating because it needs to remain available for customers because they pay for that. And so let's have an observability solution in place. Also becomes a part of the product. Like you said, throughput per topic. Well, that's in the UI. All you need to do is click on topics and you see that. If that's the same number we're talking about, right? That shows up in the UI, right?
Right. Exactly. That's the same exact number that our engineers would see or customers see. They're all coming from the same messages we collect at the source.
Which is it's important, like that you might really need to know that just by looking in the UI, but to some degree that's a little bit of sort of syrup on top of the thing. It's just, oh look, I can see the throughput, that's nice and it looks pretty, and the other parts of the system are not looking at that UI. But the metrics API, that's part of the product. That's like a meaningful, valuable feature of the thing. I don't want to turn this into a Confluent Cloud commercial, but I am putting a link in the show notes to something describing the metrics API, because if you don't know what it is, you should. And it makes sense that that's driven by the same infrastructure. So it's just kind of cool to me. And again, it shouldn't be cool; it should be obvious, but it's cool. And I'm just going to sit in the coolness for a moment. That we get both done at once. We operate the cloud and make sure it remains available, and that same data drives actual features that make it valuable.
That's right. And it's not just for the cloud. I think I'll add that. So we also have Confluent for our on-premise customers. They now have the ability to send us data to the cloud so that we can get ahead of the curve, if you want, and detect issues with their clusters and let them know about those things before they become
Yes.
problems. So that
This is the
infrastructure.
so-called proactive support feature, right?
Yes, I think the product name will probably change in the future, but um, I think proactive support is what we call that today.
Okay. Okay.
Um,
And that's all same foundation, the same instrumentation
so that's exactly the
in
same
the on-prem thing?
instrumentation. So we're using exactly the same format, the same way of collecting this data from on-premise customers and cloud customers. So it means we can reuse all the same infrastructure we've already built for the cloud for our on-prem customers, and
Nice.
that makes it very easy to then build more things on top of it.
Yeah, yeah. So there's one place that investment goes, and both types of people, whether you're on-prem or in the cloud, you can benefit either way. And this is totally sounding like a commercial. I don't mean it to be one, but that is super cool. That you can you can just double up on that investment and not have to build all that stuff twice. Because if you had to build it twice, uh, you know, one of them would be a quarter as good, and the other one would be an eighth as good. It never works out. The whole never ends up being equal to the sum of its parts there, unfortunately. So that is excellent. How about Kafka itself? Does this land on the open source stuff in any way?
So today, most of these components that we built that leverage. I mean, today it's I can say that. I mean, for Confluent Cloud and Confluent Platform, we actually use the open census format, which is also a standard. We've adopted that initially because OpenTelemetry wasn't quite mature yet. We're not mature enough yet for us to build on that. And so that was, and we started these efforts almost 2 years ago. So OpenTelemetry has come a long way since then. So now we're actually, in the process of migrating these components that collect data from Kafka brokers, and we want that to start using the OpenTelemetry format. So once we do that, I think there'll be an opportunity to also make these things available in Kafka itself. And I think it would be great to have native integration with OpenTelemetry in Kafka directly. Of course, there's a lot of other things happening at the same time, so we can't get to all of these things at once. But I want to mention one thing, which is, I mean, we're having it's not officially published yet, but there's a draft KIP out there, and which is addresses a slightly different problem, because I think having OpenTelemetry would be nice for Kafka brokers, but I think a lot of people already have instrumentation for the Kafka brokers, and so that would just be a nice to have, so to speak. When it comes to new functionality, there is something that you can't easily do today, which is to instrument your client applications. So Kafka client applications are often very difficult to instrument, or people forget to instrument them, or the Kafka clients live buried into some application that you don't have very good control over. So it's usually more difficult to instrument that. So what we're trying to do is make it easier to get data about these clients and collect that on the broker side, because brokers are usually pretty well instrumented.
Mm-hmm.
So if we can get the client to actually send us the metrics or some kind of standardized information about themselves, that can help us debug, applications that aren't behaving well, or applications that are seeing issues. Or if we're seeing issues on the brokers, we can tie them back to maybe some issues on the client side if we had this data. And I
That's
think
KIP
that
714 you're talking about, right?
that's right. So KIP 714 is basically trying to establish a protocol for the client to actually start sending metrics and other telemetry in the future to the brokers
Okay.
that then can be exposed at the broker level, and the operator of the Kafka cluster can then have visibility also into the health of the clients that are writing and reading from these clusters.
Got it. And that's why you started under the assumption that people have a broker observability solution in place. There are APIs to get stuff out of brokers. Like everybody's kind of plugged into that. So now let's try to suck client metrics into the broker through a standard mechanism. And is that then based on OpenTelemetry somehow? Is it like an assumption that OpenTelemetry is in the client, or is it not? That I haven't read the kit, obviously.
Right. So we figured like there's already a protocol out there to define metrics, and there's a well-defined format and how to transport those. So we don't want to reinvent the wheel and invent our own protocol here. So we figured, well, this is a very good fit for this particular use case. If we have these clients just basically generate the native OpenTelemetry format and then send that to the brokers can then just forward this data directly to some kind of agent and not even have to look at it. And then the cluster operator can basically get visibility to the clients without having to do much additional work. So that's kind of the idea behind that. So, and the reason is that a lot of clients it's very difficult to get access to information about these clients unless the same team is running both the broker and the clients. Usually it's hard to get the visibility you need. And I think also for us in Confluent Cloud, if we had visibility into some of the clients that are running out there, we could help our customers better and help them improve their the way that they interact with the cloud. So that that is another reason why we're doing this.
Okay.
Which will make this a lot more. Sorry?
Folks at Confluent are interested in the success of KIP 714. I guess to be more precise about that, because that would be a revolution in the ability to optimize client to cluster connections. I mean, getting all that data, and obviously this would be subject to, opting in and sharing and all of so nobody panic. It's not like we're going to start extracting a bunch of things from your clients connecting to Confluent Cloud that you didn't know were doing. But with all that happening in an organized and well-governed way, dude, that's a lot of data. And, putting that in the data warehouse somewhere, if people start asking questions about, would probably result in, my guess is, a new series of KIPs that improve other things that we don't even yet know that they need to be improved.
That's right. And there's more than just, I think, of course, everyone thinks about the Java clients usually when I think about these things. But here we're actually trying to do this in a way that is agnostic to the clients that are interacting with the cloud. So this will also be applicable to some of the other clients out there like Liberty, Kafka, or others. We're hoping that they will all implement the same functionality so that we can better understand what's happening and not make that specific to one particular client or not. Of course, I mean, there might be additional metrics that we also collect from specific versions to better understand like how they behave. And yes, I mean, making this part of the open source project is key, since most people don't use any custom client versions or Confluent version or whatever. I think we want this to be something that benefits any user. So, and those efforts have to be started early, because it takes people like years to upgrade their clients. So we want to get this in as like relatively soon, so that within a year or two we'll see some of the fruits of these efforts.
I was going to say 5, but I appreciate your optimism.
Well, I think it depends on there's early adopters out there that are always a bit more happy to go try these things out. But yeah, I think it's for people to say that things tend to be very slow on the client side, which is also what makes this harder for us, because oftentimes we know there are clients that are not behaving well because they have bugs, and until recently, it was very difficult to even figure out what client version people are running. So we've added some of that functionality in recent kit was 5.11, which makes that easier. But now if we have even more information about about the health of the client and what is going on, that will make things even more powerful, because it will not just be about, oh, we know this client has a bug. We'll be able to tell people like, oh, you have a suboptimal configuration, or like the cluster operator can help application developers tune their clients better so that they work well with the system.
Exactly. And this is a way that the whole community benefits, even people who aren't cloud users, by Kafka becoming more and more a thing that does run in the cloud, and KIPs like this being accepted and built and merged. They end up helping everybody who uses Kafka in almost any way, which is kind of cool.
And it also reduces the amount of work you have to do to instrument all your different applications, and you just have to basically instrument your broker, and then everything would flow from there. And even if the applications themselves, they can focus on their instrumentation for their actual business logic, but not have to worry too much about the client nitty-gritties, which are always kind of buried pretty deep, and may not be something that they think about much.
Right. My guest today has been Xavier Léauté. Xavier, thanks for being a part of Streaming Audio.
Thank you, Tim. It's been a pleasure.
And there you have it. Hey, you know what you get for listening to the end? Some free Confluent Cloud. Use the promo code 60PDCAST, that's 60PDCAST, to get an additional $60 of free Confluent Cloud usage. Be sure to activate it by December 31st, 2021, and use it within 90 days after activation. Any unused promo value after the expiration date is forfeit. And there are a limited number of codes available, so don't miss out. Anyway, as always, I hope this podcast was useful to you. If you want to discuss it or ask a question, you can always reach out to me on Twitter at @TLBerglund. That's TLBERGLUND. Or you can leave a comment on a YouTube video or reach out on Community Slack or on the community forum. There are sign-up links for those things in the show notes if you'd like to sign up. And while you're at it, please subscribe to our YouTube channel and to this podcast wherever fine podcasts are sold. And if you subscribe through Apple Podcasts, be sure to leave us a review there. That helps other people discover it, especially if it's a 5-star review, and we think that's a good thing. So, thanks for your support, and we'll see you next time.